Hello, everybody. My name is Matthew Virts. I'm a data scientist. I work for KBR. And what my role is, my team is kind of an embedded data scientist with the infrastructure team building a enterprise data warehouse. So this presentation, nothing groundbreaking. It's not super cutting edge high-tech stuff. But what I'd like to present today is my thoughts and my kind of thought process around big data projects. I've called this learning from the big data machine in that, creating a big data project, it kind of becomes its own thing. It has a life of its own. It becomes a mechanical process. Let's go through it. So we all probably have a pretty good idea of what we think of as big data. Big data is, it's that thing you do when you go to AWS and you say, I need 100 machines and ingest a bunch of tables. And runs queries against it. But traditionally, big data has these three B's associated with it. Volume. So I literally have a lot of data. I have to store it on a bunch of hard drives. I might have a petabyte of data. It's just storage and transmission and processing becomes a problem with a lot of data. Second B, traditionally, variety. So that can mean a lot of things, but I take it to mean, your data set is not easy to digest in terms of complexity. So, we might have, a relatively small amount of data in terms of bytes, but it's all hand-typed, maintenance records that, good luck interpreting them with a single Python script. So the complexity of the data set means that we're going to now use techniques that are basically big data because it's not something you're going to run on your laptop, and it's not something that the person would be effective at doing, basically. And then finally, velocity. Kind of self-explanatory. As you think, the amount of data per unit of time coming in is such that you need to take special care to process it. And the type of big data that I pretty much spend most of my time working on is large volume data. I have some experience with data with higher complexity. I think data has variety, but I think this is sort of, all of these projects sort of get tackled in a similar way. So, what am I talking about here? The machine, the big data machine. I think that's kind of the situation where an organization has data and wants information. So, you set up a project, you say, well, this data must be valuable. What are we going to do? We're going to take it and we're going to apply big data technology to make it into something. But the trick here is you don't really want information. Information is great, it's much better than data, but we really want value. So when you're taking that data, you have to make sure that you're steering your project in the right direction to actually make value for your organization. And of course, this will not be possible without resources. So in this case, I'm going to just say, have capital, because that's people, that's information processing systems. You can turn capital into all the things you need to make a big data project happen. So if you're going to start a project and you want to create value, you're going to have to measure your success. And success is usually what you're driving towards. But it becomes baked into the project itself. It steers every little decision people make, and what people think success is will influence their decisions even on the lower levels that you might not think as drivers of the direction of the project. So the most obvious type of success that I'm concerned with is the value success. What do we set out to do? Are we trying to track these maintenance records? We're trying to identify parts we can pull early or use for longer. That would be great because we can say, I put a dollar value on this project and we saved X number of dollars because of our big data project. That's a great measure of success, but it's not the only thing that goes into a project like this. A lot of the times, because of the complexity of the infrastructure involved, you have a lot of pride in what you're doing. You have this idea that creating the infrastructure itself is the success. And that's definitely a source of sort of misdirection. You want to be careful to avoid losing sight of the value success in favor of just infrastructure success. Now, not in every case, sometimes the infrastructure is your value. Sometimes that's what you're trying to create. The project I work on day to day, it's mostly infrastructure. Our goal does not have a very well-defined value statement, I guess. And then lastly, another type of success that can kind of, muddy the waters as to where the project like this goes is capital success. And as a government contractor, I'm very familiar with the idea of, we spent the money we wanted to spend. That's success. So, clearly that seems like a big pitfall, but it's very easy to fall into the trap of saying, we bought the hardware, we bought the software, so it must work, it must be good. We did something good today. But you always want to tie it back to value because, that's what you really set out to do, is not lose focus. So each one of these types of success, translates very easily into different roles on a project like this. And they're not necessarily roles that are well defined, they're not just all value focus or all capital focus, but they're ways of thinking about the project. And I generally think about these kind of projects, the one big one I work on, somewhere in between value and infrastructure focus, because I'm the translator between the people who have real use cases that actually matter and the infrastructure that they need to know how to use. So I don't have as much knowledge on the capital focus side of things, but I see these as the three competing factors that steer the direction of a big data project. And of course, when you're talking about changing the direction of a project, steering a project, you're going to think about leadership. The leadership usually comes from the people who start the project or who pay for it. And those people, those roles, maybe it's not one person, maybe it's part of the team, provide the purpose, which usually is the same as the value success metric. But they also provide balance, because although value is ultimately going for, you got to balance concerns for infrastructure and for capital constraints to make the project successful, to integrate the team so that people are happy with what they're doing, and you build an integrated product. But the other thing with leadership, and really leadership in terms of each individual has their own role in leadership on a project like this, is you need to reevaluate where the project is going. Because any sort of high-tech field, but especially something that is sort of intrinsically, it sounds benign, it's like, it's just big data, we need to use these technologies to handle the data so we can do cool stuff like ML, but you need to reevaluate what you're doing because the landscape changes. I can go out and buy a machine, 2 gigabyte or 2 terabytes of RAM today, and 10 years ago, there's no way I could do that. So a lot of people would use the metric of big data is anything you can't do on one machine. And that has changed so much, especially with the advent of very powerful GPUs, where you need to think, do we even really need big data in this project? Am I chasing something for the sake of chasing it, or am I really focused on that value that we're trying to create? So I think if you take all those things into consideration when you're working on a big data project, and you make sure that you're not missing any of the big picture items, you're a little bit safer from misdirecting the project and maybe missing the mark, where you all of a sudden end up with a project that it's very impressive, but it just doesn't do what you need it to do. So you have to think about these sort of things when you're beginning and middle and the end of the project, all throughout the whole thing. And I think missing some of this stuff, from my perspective, it creates heartache where you're thinking, why are we doing this way? It's like, oh, we missed a couple of essential steps along the way. So, what I want to bring up here is, I'm going to make a few statements, we're going to consider them, about big data itself, which is truly a concept. And we're going to question, are these statements valid? What other considerations are there? And what does it mean to a big data project? So, firstly, you hear big data, you think, oh, that's got to be expensive. You think a server rack, or maybe 2 or 3. And it's true, big data can be very expensive. But just like the idea of reevaluating what you're actually doing, if you need big data at all, there's a lot of technologies out there, especially with cloud, that can reduce the cost of big data to be extremely affordable. If you're talking about your big data set, being a backlog that has been collected for years, and really, you might analyze it a couple times through. Then all of a sudden, cloud is perfect because you can get the resources you need, pay for them for the 3 or 4 hours that you're going to use them for, and then stop paying for them. So big data doesn't have to be expensive, even though it definitely can be. The next statement I want to look at is big data is complicated. And that is definitely something that seems to go hand in hand, because you go from, well, I can just do this in Excel on my laptop, to, well, I can't do it in Excel anymore, so I'm going to orchestrate clusters of servers that do this computation. But when we look at what's out there already, most of the hard problems have been solved. And, most of the hard problems in terms of big data have been solved. We know how to connect computers together, run virtual machines, run containers, do container orchestration, all those things that sort of add to the complication factor of big data, have been sort of reduced to, well, okay, I'm not doing anything cutting edge, which is too crazy. I just go to Azure, I click the button, I put my credit card in, and then I can all of a sudden load an insane amount of data into a relational database system. So, sort of like the previous answer, yeah, it is complicated, but I think that the obvious level of complication is a little bit farther removed from projects today than they used to be. And there's a more subtle complication in big data in that it's not as easy to fully understand what's actually happening under the hood. You might be training some ML models on your big data set, and you might not realize that you haven't fully cleaned your data set. You might not figure it out until you get to the very end. You said, I thought I was doing the right statistics, but I was missing something, something as easy as not checking for nulls in Python, just silently ruining all of your statistics, or, something very subtle, not doing the right, language rules or something like that. So there's complications still in big data, but it is less on the infrastructure side, more on the you better know what you're doing in general side. So next, I'm going to say big data is valuable. And I think that we can all agree that's definitely true. Big data is valuable. It's a good concept, a good way of managing a data project. But it is not an intrinsic statement. It's not true all the time, because it is very easy to chase down that technology and say, oh man, I've got a couple terabytes of data on the hard drive. I'm going to go start a big data project to extract my value from that data. But you might be missing a very important point. Maybe you only need 1% of that data to extract the same amount of value. Maybe big data, you're actually wasting your time and your resources to chase a problem with the wrong technology. So big data has value, but only when used correctly. As anything, ML is certainly the same way. AI, whatever you define that is, certainly the same way. There's definitely something to look out for, because it's one of those buzzwords where you say, oh, we're building a big data system. Well, of course you're building a big data system. Yeah, that's great. But it's not always. And lastly, I'm going to leave us with big data is evolving. And really, this should be big data has evolved. I think that there have been so many changes that it's just a whole different landscape. But it's not something that we can just sit quietly and say it's a solved problem. People are coming out with new products I haven't tried, old topics that I haven't tried to make things better. But that's pretty much the main takeaway is you have to be careful when you embark on a project that is so laden with, sort of hype or maybe buzzword. And, that's what big data sort of become. So that's all I got. If you guys have any questions or any comments you'd like to say, that'd be fine. Thank you.